Just waiting for more people to show up at this point. Which will probably happen. Yeah. Just waiting for more than 2 people. Hey, welcome to the party. Oh, you know, I'm alive. It works. As usual, I'd rather be off playing video games or something, but yeah.
But you're here.
Well, I guess the halfway point's about where the class is gonna die out, huh? Alright. All right, who just joined the Zoom meeting under the name of Loner? Bit of a quiet night so far.
Yeah. Oh, you got some students on the.
Yeah. Got a couple people online. One of which doesn't have a name.
I've seen that happen a lot. I know.
Mm-hmm.
Robert.
Hey, the person who just got the request to unmute, what is your name? Gotta record attendance somehow. Alright.
I thought there was all before. Before I thought it was that Sicilian chick that was with us.
Oh, yeah. I don't know, we're at the halfway point. This is usually when things start dropping a little bit, and the fact that I have a grand total of, 4 students is a little telling of that.
Thanks.
But, it'll be fine. All right. Well, might as well just get started. You have unmuted. Who are you?
Oh shit, I'm Loner.
You're a
It's
liar.
Robert.
There he is.
Now we know.
You ain't a loner, big dog. I'm here.
I'm fixing it now.
Doesn't matter. Now that I know who you are, I'm good with it. I'm just making a note of
Hey,
it.
my parents gave me a name.
You don't get a name. Rename people?
Well, apparently I don't. Oh, there it went.
All right, let's be a horrible person. Hey, look, I can apparently rename you. Now you're Bobbert.
You know what's funny? I've actually been called that a lot
That's
by
fair.
my family.
That's fair. I once ordered from Burger King from a guy with a very thick accent, and he asked me my name, and I was like, Ben Bun? No, Ben Bun? Ben Bun? All right. I get my receipt, and it says Bell, B-E-L. Like, how did that happen? And then, oh God, somebody completely different called out my order, and he looked so confused. Because how do you call the name B-E-L? He was like, Bill? Yeah, good enough.
Oh, wow.
So we went from Ben to Bond to Bell to Bill. Reasonably, that stuck in my head. It was a wonderful 4-name trip. All right. Can I make these screens shorter? No, I can't adjust anything here. Okay, that's cool. I don't care enough. All right. Now I need to sneeze.
Bless you.
All right. Good one.
That sounded bad.
Rowboat cop. Part man, part boat, all cops. The future of water-based law enforcement. All right, so tonight we're going to be doing, believe it or not, some review. Which you are gonna have to do some on your own. Because everybody loved the greatest common factor, least common multiple thing last time, so let's do more.
I got stuff on the computer.
Everybody hates that. And yeah.
Yeah, and I even try to get the kids to help me, but
That method is really weird and it's not taught too often. But the problem is, I can't find a better way to teach it.
yeah.
I've been tutoring and teaching and, all of the above since 2008. And that's like the main thing that I have trouble teaching because it's not a great way to get the idea across.
Yeah.
Drives me nuts. Ah, but speaking of the idea, here's the idea. So the greatest common factor of two or more numbers is defined as the largest number that is a factor of all the numbers. So the greatest common factor of 12 and 9 would be 3 because it's the biggest thing that can fit into either one. The least common multiple is kind of the other way around. The LCM of two or more numbers is the smallest number, non-zero, that is a multiple of all the numbers. So the LCM of 12 and 9 would be 36 because it's the first number that both 12 and 9 can fit into. So greatest common factor is the biggest thing that can fit into them. LCM is the smallest thing that they can fit into. So kind of the other way around. That's why I had like one method to do it. Speaking of that
So
method,
quick question.
quick answer.
The greatest common factor is always going to be smaller than the least common multiple.
Suppose it depends on the situation. I'm gonna say it's usually true, but the only time it wouldn't be true is if all the numbers are like really stupidly close together or the same number across the board. Otherwise, yeah, pretty much. GCF is gonna be the smaller one, LCM is gonna be the bigger one. Now, I will say that usually you're not gonna have to find both at the same time. It just so happens that the method I use was easy enough to teach both at the same time. So usually you'll be finding one or the other.
You gonna read you one?
Yeah, so we're gonna do these ones together. And then there's a couple, literally just like two, I think. Yeah, two that I'm gonna have you guys do on your own. And I have the feeling that we're gonna do them together anyway afterwards, but we're.
Sorry. I
It,
think, it just clicked. The LCM and GCM both.
seeing them both on the same
Yeah,
slide, pretty much.
yeah.
Well, let's find out. So again, I'm gonna, like last time, do this the long way and the short way. Both ways, see if it works out good. And make this a little wider, yeah. Yeah, okay, that's kind of funky, whatever, I don't care. All right, so. Ooh, this is at an angle. All right. Good enough, okay. So with all of these, we're gonna go ahead and get the prime factorization of each one, so factor tree. This one's 7 times 11. This one's 9 times 11, and the 9 can break down further. And the 121 is 11 times 11. Made it nice and basic for a reason, right? Now we're going to find the greatest common factor and the least common multiple. So last time I tried out just starting from the highest number and working my way down. Doesn't really matter. So 121 is 11 times 11, so each of those is going to get a column. 99 was 11 times 3 times 3. Since we have an 11, it has to go into the first column that we have an 11 in. We don't have a column for any 3s, so each of those is going to get its own column. And 77 is 7 times 11. That 11 is going to have to go into that first 11 column. The 7 gets its own. You probably already could have guessed what the greatest common factor is, because every single one of these is divisible by 11. And greatest common factor, while doing this method, it's the only the things that are represented on every single row. So just this one. And you can see that by looking at your factor trees and saying, hey, what's common to everything? An 11, an 11, and 11. Anything else? This still has a 7, this still has 2 3s, this still has an 11, nothing in common, right? So you could see the greatest common factor pretty easily with a factor tree, but not so much the least common multiple. That's going to be the next line. Might as well do them both all at once, right? And remember, least common multiple is going to take one of each column. And depending on what you're working with, is usually going to be a big stupid number. Which in this case, it is 7,623.
That's not a weird number.
You're a weird number. Yes, right. That's what I thought. All right. I'm an adult. I am no more professional while I'm working as a phlebotomist. For the record, I will be standing there swinging the needle on the needle line like an idiot. Like, don't worry, you're probably going to be okay. Do we have your next of kin on file?
Did you say Mexican or next of kin?
Next of kin. My Mexican lives on my couch and usually does our cooking. Yeah, that'd be my brother.
Oh, the computer speaker made it sound like Mexican. I had my Mexican. I was like, wait, what?
It's okay. It's okay. I'll allow it. Yeah, I'm the whitest half Spanish guy you'll ever see in your life. Yeah, you should see me dance. That like takes the white to a whole nother level.
Hey, I don't think it's on a dance.
Doesn't matter. I am a stereotype of bat. All right, like if somebody loses their dog or something, all they gotta do is ask me to dance because that dog will start howling just knowing that that's out there. All right. All right. So that's greatest common factor and least common multiple. So greatest common factor we can see by the factor trees quite easily. But the least common multiple by the factor trees is a little tougher. And remember, that method is just looking at this, starting with your smallest factor, just to keep things straight and saying, okay, what's the smallest factor I got? 3, right? Okay, this has none, this has 2, this has none. I will need those 2, because the idea is to have every single, like every factor from this has to fit into it, every factor from this has to fit into it, and every factor from this has to fit into it. Otherwise, it's not going to work. You have to be able to look at it and say, every one of these factors fits into my LCM. So there's the 3s. The next one up is 7, 1, none, and none. So we need the 1. And then the 11s, 1, 1. Well, this one has 2, so we would need the 2. And remember, the idea is to be able to say, hey, 77 is 7 times 11. Do we have that in here? Yeah, there's a 7 and 11. This one is 2 3s and 11. 2 3s and an 11, okay, and this one's 2 11s, 2 11s. So all of our bases are covered here. And that's when you'd multiply them together, we still have the exact same numbers here, so you end up with the exact same thing. Now, for the record, this is the way I do it, because it's a little quicker if you understand it. This is a faster way to do it. If you don't understand it, this is kind of an okay way to do it. Not the best, but not the worst. Let's do more. We have 8, 18, 28, and 48. 8's all over the place. I should add a 38 in there just for funsies. All right, so as usual, factor all the way down. 8's a bunch of 2s. 18's a 2 and a couple of 3s. 28's a couple of 2s and a 7. And 48's a ton of 2s and a 3. I'm gonna tell you right now, since that one has the most amount of 2s, our least common multiple is gonna have that many 2s. Just because that's the most amount of 2s that any of these guys have. So again, I'm gonna go ahead and write out all of my numbers. And then I'll write out their factors across. So 48, we have 4 2s and a 3. And the next one down is 28. That one has 2 2s and a 7. So first 2 2s go here. We don't have a column for 7, so we make one. 18, we have a 2 and 2 3s. So the 2's easy enough. First 3 is easy enough, but we don't have a column for the other 3, so it gets its own. And then number 8 here is 3 2s. Well, we have columns for each of those, so there we are. Okay. Now, before I do this way, let's see if we can pull it off up here. Now, greatest common factor is kind of easy. They all have a 2 in common. But nothing past that, right? This one doesn't have any more 2s. Everything else has 2s, but yeah, that's it. So that's the biggest thing that can fit into all of them. And if I had to do the least common multiple at this point, I would go through and say, okay, well, 2s, this one has 3, this one has 1, this one has 2, this one has 4. That's the most amount of 2s, so that's how many we gotta have. And the next one up would be 3. This one has none, 2, none, 1. So the most amount of 3s any of these has is 2 of them. And then the next factor up would be a 7. None of these have a 7 except for 28. So we would need that 7. Let's look at this method to see if we end up with the same thing. GCF, definitely a 2, nothing else. LCM, 2, 2, 2. I hate you, pen. Start writing better. 2, 3, 7, and 3. Well, it's not in the same order, but that is exactly the same thing that we have up here, right? Well, I don't know what that is, but it's probably 48 times a 7 and a 3. $1,008. Yeah, just like the last one, there's 2 different methods of being able to do it. If you can understand this way, it's quicker. If you can't understand this way, again, this is pretty much the only boat we gotta be able to jump on. Cool. We enjoying ourselves?
Mm-mm.
All right, well, number 3. Here's an obvious hint. That one's gonna deal with the number 11. We have 11, 121, and 143. Now 11 is prime. So that one can't be factored any further. And also, since that's kind of a small number, we can keep in mind that the absolute biggest, the greatest common factor could be, is that smallest number, because nothing bigger than that can fit into it, right? So the biggest, greatest common factor we could have is 11. Now 143, I'm sure that's divisible by 11. Yep, it is 11 times 13. Let's just look at it this way. Greatest common factor. This has an 11, this has a couple 11s, this has an 11. Guess what our greatest common factor is? No, it's 5. No, it's 11. Yeah. Yeah. Wonder if I started writing out some weird proof, trying to quote unquote show it being 5, how long it would be until somebody stops me and says you are making all of this up. You are absolutely full of it. Okay. Okay, so the least common multiple, we only have 11s and 13s. This one has an 11, this one has an 11, but this one has 2. So we have to go with the 2 of them. And then the 13, this one has a 13, so we need the 13. We need to have all of our factors represented. 11 goes into it, yep. 2 11s go into it, yep. An 11 and a 13 go into it, yep. All right, so that's our LCM. Now, what is it? I don't know, something awful. It's 143 times 11. 1,573. So yeah, without that grid-based way of doing it, this is pretty much how much space you should be using. Now, do we need to see it the other way on this one? Acceptable answers are both yes and no.
No.
No? Okay, you feeling good about this method? Ish?
If
Ish. All right. Well, do it yourself. Now we got two of these. Gonna give you about 6 minutes to work them out. You could do them either way with the factor trees or by doing a factor tree and then with that grid. Either way, you want to find both the greatest common factor and least common multiple of both of those. And let me know if you have any questions. How's everybody doing? It's notably quite quiet.
Yeah, our brain is trying to work.
I'll give you all a couple more minutes. I don't know how long everybody's taking. I only got one visual here.
I got stuck on 68, 56.
You're stuck on them as in factoring them?
Multiplying that high.
Okay, okay. Well, I'll give it another minute and we'll work on both.
See.
All right, I think that's long enough. How do we feel about this? How did we do? We hate everything.
I think I got the gist of it, just those two, I don't know how much plan, what they want to play.
Okay, okay. Well, it's not too bad being able to let you know, not being able to multiply stuff right now, because when you're, actually being, assessed on these things or in the tests or what have you, you are going to have a scientific calculator.
Yeah,
So, like if you do it here, then you get provided one of these guys,
yeah,
which I've already nerded up because I can.
nice,
I regret nothing.
yeah.
I also am going to The new Zelda comes out on the 12th. I have already taken it off as a vacation. I am going to prepare my class for the Tuesday following before the game comes out, and I am not going to move. I am going to be door dashing and yeah, no. Wake up, play the game, go to sleep, wake up, play the game, go to sleep. That's the plan. That's the plan. Yeah. My girlfriend wants to bond over that time. I have ordered a small capture card so she can just pop into the stream.
That's
Yeah,
mean.
people. What was that?
That's mean.
It's not mean. She wants to watch the game too. She likes Zelda. She actually played the last one.
Okay, then never mind.
Yeah, it's cool. It's cool. It's cool. Plus, this week I'm upgrading to the Zelda edition of the Switch. And I'm going to have a spare Switch and she's gonna get the other one. So
Hey, she gets it too.
yeah, she.
See, that's not mean.
Yeah, exactly. Now I just gotta save up for some extra games. So, I could throw those at her. At the very least, Animal Crossing has to happen. All right. Well, for number 1 and number 2, this is what I got. Anybody else get something similar? Or make it that far? That's an option?
No, am I?
The GCF I got was right.
All right. I'm cool with that. Echo. Oh, all right. Well, let's take a look at this guy. So each one of these, of course, we're going to factor tree all the way down. 16 is 2 times 8, which is 2 times 4, which is 2 times 2, bunch of 2s. 24, we got 2 times 12, 2 and 6, 2 and 3, good enough. 68. Well, if you don't know, you can chop each digit in half. Half of 6 is 3, half of 8 is 4, so 34. And then that one's even, so we know a 2 can still go into that. Half of 34, well, half of 30 is 15, half of 4 is 2, so 15 and 2, 17. It's cheap, but it works.
No, and I know that's what I'm trying to like, all right.
This is gonna break me back into my argument that I like Common Core math, because that's literally one way things are taught. Is being able to do math in your head this way, is taking 34, splitting it up as 30 and 4. You're getting half of each one. So you'd have 15 and 2. Is that how you'd actually write it? I don't know. I don't care. That works in my brain. So you know what? That's how I actually write it. I don't care. But yeah, that's that's how that works. That's why I like Common Core math. I just wish they would actually, properly teach the teachers before rolling things out and confusing the hell out of the entire planet. So let's take a look here. Let's do it the grid way. So 68 was 2 2s and a 17. And I did stop at 17 because it's prime. If you don't know why, then start trying to divide 17 by anything evenly. You're not going to find anything. 24, we got 3 2s and a 3. We already have columns for 2 of those 2s, so we need another one for that third 2 and one for that 3. Then 16 is 2s all the way down, 4 2s. 1, 2, 3, and we don't have a column for a 4th, so 4. Okay, so the greatest common factor is whatever they have in common. In this case, it's 2 2s. So we'd multiply them together and we would get 4. The least common multiple. You take one thing from every column. All right, and I'm gonna punch that into the calculator here, because I don't have a freaking clue. 816. Oh, I guess I actually do have it written up here. Whatever, I don't care. We're doing the actual work.
So basically, the LCM is all of the numbers that's not in the greatest common factor, and you're multiplying all that together.
The LCM doesn't have anything to do with what the greatest common factor is. It's
The extra
know.
numbers that are left over, right? That's what I'm trying to say.
no, it is not. It is essentially, it's all of the factors that will be able, that all of your factors up here would be able to fit into. So that's why we're taking one from every single column, because if I looked at this 16 and I said, oh, that's 4 2s, do I have 4 2s represented in this LCM? 1, 2, 3, 4. Yes. 3 2s and a 3. 3 2s and a 3. Yes. And 68 is 2 2s and a 17. There's my 2 2s and a 17. So you're making sure that you have all of the factors represented in one number. So this is a multiple of every single one of these. It's perfectly, 816 is perfectly divisible by every single one of these.
Okay.
Yeah, so if you're on a test and you threw this together and you're like, oh God, I don't know if that's right. Take that, divide it by each of these and see if it comes out even. If it's even, you got a pretty decent chance of it being right. If it comes out and you spits out a decimal somewhere, that's a problem.
Okay.
Yeah.
So it's the multiples that can't be broken down anymore.
Yeah, essentially. Yeah, because these are prime factors. And we just make sure that all of our prime factors are represented here. And again, the other way to look at this is to say, hey, start with whatever factor you feel like and say, I need to have in my LCM the most amount of that factor that any of these individual numbers has. So this has 4 2s, 3 2s, and 2 2s. So you have to go with the largest amount of 2s there. So that's 4 of them. And then the next one up is 3s. This one has 1, so we need 1. 17s, this one has 1, so we need 1. That way, everything from these factor trees is represented in this number. What it multiplies out to, I don't actually care. It's just that all the factors are there, that's what matters. Any further questions on this one?
So what happens if you were to write out the 4 2s, write out the 4 2s on the 16s, and then you write out the 3 2s on the other one. And then
So
the
if you
2
put
2s
all of it together,
yeah.
well, if you put all of it together, you'd have 16, 24, and 68 multiplied together, 26,112. Now, I
So
will
that-
tell you that is a common multiple, because if I multiply this out, eventually I'm going to hit that number. Same with both of these guys. But the aim is, well, the L stands for least. So you're looking for the smallest one. Now, practically, it depends on what you're doing. If I'm in a hurry and it's not going to produce something giant and horrifying, like, 26,000, I might just resort to that. Because usually you'll use it in situations where the best example is always least common, lowest common denominator, where you're trying to add fractions together. If you do it that way, you're pretty much guaranteed to have something big and ugly to reduce at the end, but it will work. I just, so that, you know, I don't recommend it too well. But yeah, it's a possibility, but it wouldn't be an answer for LCM. Let's do another one. 32, 56, and 88. Okay, so breaking this down, you can break them down however you want. I'm gonna go ahead and call this one 4 times 8. Just because, honestly, it's gonna save me room. Because 32 ends up being 5 2s. 56. That's 2 and 28, and 28's not bad. That's 14 and breaks down to 2 and 7. So we get a bunch of 2s and a 7. 88. I'm gonna call that one 11 times 8. So 2 and 4 and 2 and 2 there. So you can see we got a ton of 2s all over the place.
I have a question.
I have an answer.
So why don't and on the line of 32, why don't we, or we can do like 32 divided by 2
You can.
twice 16?
Yeah, you can. I just chose this just because honestly, I'm like that far away from the end of the paper. So I just didn't want that many rows all the way down because it would have reached down here. But yeah, you can. It doesn't matter how you break these down. You are always going to end up with the same factors.
Okay,
So-
yes,
Sorry, go
because I did twice 16 and yeah, it ends with 2 at the end.
Yeah, so you end up with 5 2s total, right?
Yep, yes. 5
Exactly.
2s total.
So it
All right.
doesn't matter how it goes down, you always end up with the same numbers.
Oh, okay.
Yeah,
I got it. Okay.
cool. So let's go ahead and do our little chart thingy. So 88 was 3 2s and 11. $56, 3 2s and a 7. Oh, I almost wrote it right there. That is not an 11. And 32 is 5 2s. So we got columns for 3 of them, but not columns for the other 2. So the greatest common factor is whatever columns they all have filled out. Yeah, you are correct. So yeah, our greatest common factor is 3 2s that are all going to get multiplied together. So yes, you do get 8. And least common multiple is one thing from every single column. And you multiply those as out and you get 2,464. Okay. Do we have any questions on that one? Well, me neither. All right. So now the only other thing we have left for that particular idea is just a little bit more advanced on the lowest common denominator, which, like I said, is pretty much the LCM applied. So the LCD, that's when you're dealing with fractions and you're combining them with either addition or subtraction, you're getting the denominators to be the same. The lowest common denominator is the same concept as least common multiple. The only difference is that LCD is fraction, LCM is just random numbers. So the work in finding LCM can be used to find more difficult LCDs in the future. So if you have uglier fractions, the way that we just learned how to find the least common multiple can help put those together. So I'm thinking based on how much time we just spent on all of that, I'm thinking I'm just going to do number 3 and 4. Write those down real quick. Just write down the first one for now. Now, you can absolutely do that whole chart method, but for the most part, when you're applying these concepts, at least in math classes, you're probably going to get spoon-fed smaller numbers that you can deal with easier, right? Be kind of funky if they went out of their way to make every step along the way the hardest it can be, because the idea here is to just understand what's happening. And what we're understanding is that we need all of these guys to be over the same number, right? So what we can do is factor all of the denominators out. And in this case, it's quite nice because everything's a bunch of 5s, right? 2 5s, 3 5s, and 1 5. So guess what our LCD is going to be? Well, it'd have to be the most amount of 5s, right? Under 25. Because again, you can't work these guys all down to 5, but you can at the very least beef them up to be that 125, right? Okay, so I'm going to rewrite here. And then you just multiply top and bottom by whatever they're missing to get it up to 125. This one already had 2 5s, so it only needs 1 more. This one doesn't need anything more because it's already over 125. This one had 1 5 out of 3, so it needs 2 more. That would be 25. And of course, when you're dealing with fractions like this, you just multiply straight across. So we'll end up with 20 over 125 minus 6 over 125 plus 75 over 125. So we know when we combine these, it's still going to be over 125. And then we can do 20 minus 6 plus 75 on top. You can do this however you want. You can do 20 minus 6, figure out that's 14, then add it to 75. You can do 20 plus 75 and then subtract 6. It's gonna work out regardless, because remember, we have those commutative properties to fall back on. But either way, you're gonna end up with an 89. Now, 89, I don't know if it breaks down, but I know that 125 is just a bunch of fives, and I can very much tell that 5 doesn't go into 89 evenly. Which means this isn't going to reduce any further. That's as good as we're gonna get. Does that make sense? Pretty decently, right? Not a bad one.
Mhm.
I don't remember what I have for the next one though, so let's find out. Okay, that one's negative 14 21sts plus 1/3 plus 12 70ths. Not the prettiest, right? Now, one thing you can do is you can absolutely, if you can see that these fractions can reduce, you can either charge through and find the least common multiple right now, the LCD, or you can reduce them now and then find the LCD afterwards, because either way, you're going to end up having to do some reduction at one point or another. But if I reduce now, I'll probably have to deal with a significantly less ugly LCD, right? So I'm going to deal with smaller numbers. So yeah, that first one, I can put 7 into the top and bottom, right? 7 goes into here twice, and 7 goes into here 3 times. You can already see that this is going to work out nicely. Now 12 over 70. 12 doesn't go into 70 perfectly, but they're both even numbers. So 2 goes into here 6 times, and 2 goes into here 35 times. All right, well, let's see what we can do from this. Because we can, you know, we could do this a couple of different ways. I can even, if you'd like to, we can even combine these two right away, because these do have a common denominator already.
Yeah.
-2 plus 1, that'd be a -1. Now, since we've done all this reducing and combinations before we went to the trouble of finding the LCD, this one actually is going to end up working out to be probably Robert's favorite thing. Because 35, that just factors to 5 times 7, right? So the only thing I can do to get an LCD is kind of multiply them together. Right? So we'd have to have a 3, 5, and 7 for our lowest common denominator. What would that be? 105? 105. Now, that would not have been that nice if I didn't start breaking things down to start, right? Let's see, out of curiosity, what would we have ended up with?
Wait, I have a question.
I have an answer.
Okay, so because the 3 doesn't go, or because the 3 can't go into anything like the 35, you have to add the 3 onto the 5, 7 to get your common denominator?
Essentially, yeah, because if you think about how to get a common denominator, there are things that work their way up to having the same number, right?
Right.
And 3 doesn't go nicely into 35.
Okay, I see now.
Yeah, exactly.
Okay.
Now, if I had actually started off with the 21, 3, and 70 and just left them as is and found the common denominator there, we actually would have ended up with another 2. And our LCD would have actually been 210. And we would have to be multiplying these things to get them up to 210. This one I'd multiply by 70 over itself. This one by 10 over itself, this one by 3 over itself. And it would have been a lot messier, right? But in this case, since we did it this way, we have smaller numbers to work with. So I'm gonna go ahead and rewrite this so we can see it a little better. Now to get our common denominator, this one's gonna multiply by 35 over itself. And this one's gonna multiply by 3 over itself. So we get negative 35 over 105 plus 18 over 105. So when we add them together, we end up with something over 105. We get negative 35 plus 18. You could look at it as 18 minus 35. Either way, you're going to end up finding the difference between these two numbers, which would be 17, and go with the larger one's sign, so a negative. Because if you have 18 bucks, you take away 35, you are in the hole. All right, how do we like it? Application wise, a little bit easier than doing the whole grid stuff, right?
Oh, yeah.
Don't worry, greatest common factor will come back eventually too. Except usually with A's, B's, C's, X's, Y's, etc. Actually has better applications in algebra. All right. Do we feel confident in leaving this in the past?
Sure.
At least for now. Okay. Percentages. I love percentages. As per my last email. You ever have to write a very condescending email at work replying to somebody who's ignoring you? You put as per my last email as like a middle finger of you can't read. It's like the email equivalent of the Southern lady saying, "Oh, bless your heart." Okay, so percent means parts per 100. The word itself is percent, right? So makes sense. Based on this information, if you were to examine 25%, you could think of it as 25 out of 100 because 25% is 25 parts per 100. So you can very easily look at it as a fraction that way and, you know, work it out with proportions like we've done before, or, you know, however you really want to do it. You could reduce that as a fraction and have like a nice fraction to work with it as. You know, you have a lot of different options just based on that concept.
Yeah.
Now converting them to decimals, surprisingly easy. Because hey, if you 25% means you have 25 out of 100. Well, to find the decimal form of a fraction, you actually would just take the top one, divide it by the bottom one. 25 divided by 100 just shifts the decimal over twice, basically. So you get 0.25 after that. So you just drop the percentage symbol and move the decimal over twice. Works out every time. And then converting from a decimal to a percentage goes the other way around. You just multiply it by 100 and add the symbol. Not too bad. Not too bad. All right, converting percentages to from decimals a little further. Yeah, so like I have here. It's all just about moving the decimal point over a couple of times and pulling on the percent symbol when you need it. Not honestly bad. I don't know why I have this many slides for this. Totally gonna cut this down in future classes. Too many slides. I think I could actually have had the last 4 slides as one big ugly slide. All right. 100%. Oh yeah. So converting them to a fraction. Pretty easy. You just take the 25%, put it over 100. You say, yay, I have 25 over 100. Then you would reduce it. 25 goes into itself once, 25 goes into 100 4 times. So 25% is 1/4. Makes sense? It's a quarter. You could do that with any percentage. 55% here is an example. 55 over 100 reduces to 11 over 20. So you can find the fraction form of a percentage pretty easily. Okay. Now, how about we do a bunch of these? Just convert it. They're very quick. They're very easy. I really love this guy's art of drawing giant birds in front of armies. Let's see if he runs a shop and order a print or something. I don't know. Like to see a goose like taking out a couple hundred people or something. All right. I'm gonna write a bunch of these down because they are going to be really quick.
It's also quicker if you do them all with us.
I mean, I am gonna do all of these with you. That doesn't mean anything about the next slide.
That's not needed.
I'm not here to reassure you. I'm here to torture you a little bit until it clicks. I'm sure that that's not the way that everybody would like that phrased, but I mean, let's face it, I'm a math teacher. What else am I gonna do?
Torture us with math.
Exactly. I mean, my other job is stabbing people in the arm with a needle, so I mean,
You win no matter what.
yeah. Like I tell them all the time, it's, you know, it's not so bad. The problem is you have to do it properly. I always like to freak them out, like, yeah, you got a vein in there somewhere. If we keep going, we'll find blood eventually. Been there for a while, haven't seen anybody hit a tendon or anything yet. And I've heard that if you were to do that, you would know, and they would know, and everybody in the building would know. Yup. They got like, forget if it's 16 gauge or 17 gauge needles. They're decent size.
And I'm the sick person that doesn't care what size needle you stab me with.
I always weird everybody out because I swear that, like, honestly, for some reason, the smaller ones freak me out more. I don't know. They just, I don't know. They look almost sharper. I don't know. It's like, I don't know. Just a needle thing. I don't know.
I just look away.
Look away.
But my kids operated with 9 ones, so I saw them and I was like, whatever. But you're just doing the stomach to see through it.
Yeah, pretty much. I mean, really, like, it's really easy on everybody's system. The only people I see that have like I mean, some people might not eat or whatever well beforehand and they'll get a little dizzy and I haven't seen any problem that can't be fixed with 5 minutes rest and a Gatorade.
That's true, because even when I get back into exercising right away, I have to have an extra Gatorade right afterwards.
Yeah. No, they get really wiped out, get dizzy and, you know, every once in a while they'll pass out. Hey, talk to me, wake up. Sip some of this Gatorade, you're good. Cause that's what happens when your blood's out of your body for a little bit,
Yeah.
but we put it back. The red blood cells go back, it's fine. All right,
Maybe you can answer that question. How long after a tattoo can you?
I think it's like 4 months.
Okay.
I could be wrong, cause I haven't been like
Well, that's
formally
not better than
trained.
I heard, for like 7 years, only 7 years, like, that's a lot.
No. I forget if it's 4 months or 6 months, it's something like that.
Okay.
Yeah. But I mean, plasma's easy on your system, so like people come in 2 days later and donate again. So
How much did you spend last time?
money, like $100 a weekish. God, I gotta start doing that.
I'll see you soon.
You can also sell your testicle.
Yeah, but mine's worthless now.
I'm not using it. Yeah, it's a good idea. All right.
I don't think they take me.
I don't know. I'm pretty useless all around, so I don't donate plasma just because I'm pretty sure if it came out of me, it would look like sludge. I'm not kidding. When somebody donates and they've been eating really fatty foods, it comes out with a bunch of fat.
That's not good.
Yeah, no, the machine starts alarming and then we have to it ends up ending early and yeah.
Well, then I'll be having fast.
Yeah. Yeah, you eat something that's not greasy beforehand, then right afterwards, like eat a high protein meal. Everybody ends up going in and out or something.
What if I got a T-bone steak?
That sounds great. I had Arnolfo's for lunch and I'm still hungry.
Took my son into Denny's and had that together.
Denny's.
Yeah. Little T-bone steak.
Anytime I go to Denny's, I associate Denny's with breakfast food. I forget they have anything other than that.
I went for breakfast.
Yeah.
I had eggs with-
They got a burger with an egg patty on it or whatever.
Hell
Really?
yeah.
Yeah, it's so good.
It's amazing when when you pop the yolk on it.
Easy or however you want.
I don't know, eggs are
Eggs
eggs, yeah, but no, you put it on there. I think it was like, there was also, I think I went to Mel's at one point and they ground the thing in like buffalo sauce or something.
Yeah.
I think at some point I'm gonna go into Denny's and be like, give me that breakfast burger and a bottle of like Tabasco or something. And let's see if you can kill me. All right. Hey, look, we have all of these. Let's do them. So you can see my little shorthand of being lazy about this. This one's just going to decimal, to fractions, to percentages, etc. So converting it to a decimal, real easy. You find where the decimal would be right now, and we're just going to move it over to the left twice. So 63% is 0.63. Now, if you're ever confused about that, if you're like, oh God, which way goes what, right? Because that's a mistake people make. Maybe you might have wanted to put it over this way. Just remember that 1 is 100%. If you remember it that way, usually gonna work out okay. But yeah, that's the amount of work that's involved in doing this. Now, number 2, we have 45% turning into a fraction. So remember, percentages are out of 100. So we have 45 out of 100. And then you can reduce it. 5 goes into here, how many times? 9? And 5 goes into here 20 times. Won't reduce any further. So that's all we needed. .15 to a percentage. Shift that decimal point over twice. We get 15, slap a percentage symbol on it, and we're golden.
You put 1 before 5. Oh,
Yeah, because we had 0.15. And to convert that, we move over the decimal point twice. So it ends up after that 5. We don't really have to write it anymore at that point. But it would kind of be like right there.
So what if it was 0.153?
Oh, you'll see in a second. I got this guy. You'll see in a second.
Yeah, but the zeros are easy.
Oh, God. Oh, my God. I want to do the your mom thing, but that's messed up. All right.
My mom was very
Oh,
Oh, God.
My mom is easy too.
okay.
This is being recorded, right?
Yes. Yeah, you could get me fired if you'd like to. I respect it.
No, just so you can get a kick out of it at home too.
I like the Yo Mama jokes.
I mean, after a certain, it's like playing Pokemon games. You're a little kid, you're like, this is funny. Then you get a little older, no, that's stupid. Then you get older and you're like, it's funny again.
My mom was a prostitute when I was in high school. There's
Yeah?
no Yo Mama joke that I haven't heard that I haven't laughed at.
That's hardcore. I respect it. It is the oldest profession. And some people are the oldest out there still in that profession.
Thank God my mom's not anymore. She's old as hell.
And me and
I was drinking, man. I was drinking.
me and my friends like to be outside.
Yeah. What a surprise.
Oh,
All right. All right, let's do these 3 more and then I'm gonna cut you loose on a bunch of them.
Sounds fun.
And by a bunch of them, I mean about this many. I actually,
I thought you were making a Yo Mama joke again.
you ever hear the town bicycle joke?
Yeah.
Yeah.
Have you
I
heard
like
the-
I like to switch it over to a bus service, 20 people at once and everybody pays a dollar. All right.
the city light switch?
Ooh, that's rough. Okay, I apologize to everyone else on here who is just horribly offended by this stuff. If you want to send me a strongly worded email, I will accept it and there will be no repercussions in any way, shape, or form. Like, just, let the mouth go free. I don't care. I respect it. All right.
That is so
Okay.
weird.
So, yeah, I did a disconnect on somebody yesterday. I didn't do their needle stick, but I did the disconnect. And after they left, I was like, wait a minute. I'm pretty sure when I worked at GameStop, they complained about me. They called the store to complain about me, and their entire family stopped going in. I don't feel bad about it. Their kids brought in a box of video games to sell, and they were soaked in like animal urine. Like, oh God, I kept having to wash my hands. That was so nasty. All right. Don't feel bad
I
about
thought
it.
Walmart was bad.
What? I'm so confused. All right, here we go. Let's do this one. This one's converting to decimal. Look at how hard it is. Oh.
What happens to the 5? Oh, it's the-
Oh, it's still there. That's the thing with decimals. Even if something's moving over, the numbers you got are still there. So that is essentially what's happening with this guy over here. You're converting this guy to a percentage, and you have to move that decimal over twice. And your question is, hey, what happens to that after that second digit? Well, nothing. That's just where the decimal is now. It just so happens that we have a decimal in a percentage. Now you might ask, why the heck am I needing all these different ways to represent the same thing? Because I have another 30 slides on here. Because there are applications. Let's do another one where it's going to fractions. Now, I particularly love 60% because I like being able to look at those zeros on the end and going, hey, 10 divided by 10. Love it. So 60 out of 100 is the same as 6 over 10. And I can reduce that pretty nicely. 2 goes into there 3 times and 2 goes into there 5 times. And if anyone has the question, does this always work? The answer is yes. You can always reduce those ending zeros. Do we have any questions on these 6 problems that I would have done very quickly if not for a horrible tangent of offensive jokes?
Yep, please, in the last one. I didn't catch really good this one.
What was that? This last one?
Yep, yeah, the last one, please, yeah.
Okay. So the idea here is that we have 60%. 60% is the same as 60 out of 100. Welcome to the class. I don't like to call people out for being late, but honestly, it just sounds fun right now. You're late.
Maybe just 10.
Just an hour and a half. All right. I don't know, man. This is a college. It's everybody else's education. Could be worse. I had a teacher at a university once who, if you answered a cell phone or wore a hat into his class, he would kick you out immediately. And one guy wore a hat and answered his phone. He full on stopped the class, threw his chalk at him, had the biggest look of rage on his face. Get out. I'm sorry. Get out. And he just stared him down until he walked out, the door closed, and then he went back to class like nothing happened. I was like, oh, I'm not making this guy angry. Oh, yeah. I also decided I was never going to be that kind of teacher. I feel like that's bad for the learning process. At the very least, it was bad for that guy's learning process. But I can guarantee you he never showed up with a hat on ever again. Okay, so the question is, oh my God, this one was weird. What was going on there? So
Yeah.
the idea here is that with these zeros at the end, since I know that this makes this 6 times 10 and that makes this 10 times 10, I can immediately reduce it by 10 by saying, hey, 10 goes into here 6 times and 10 goes into here 10 times. And I can do that short by just shopping through those zeros. As long as I have a 0 on the end of the top and on the bottom, I can chop those out right away. Now, from this point, all you can really reduce is that 6/10, which they're both even. So you could say, oh, 2 goes into here 3 times and 2 goes into here 5 times. So that's where you get the
Okay.
3/5.
I got it.
Cool.
Okay, okay, thank you.
What if the zeros are at the end?
What was that?
What if the zeros aren't at the end? Like, what if it was like 601 over 100?
Then
Did you
that
still
sucks.
take out
And
the-
you- and you can't do that. Like, that's not gonna have a nice, easy shortcut. You just have to break
No.
down 601 over 100, which I'm pretty sure isn't gonna work out too nicely. Like converting that to a decimal would be great, but converting it to a fraction would probably just be leaving it as 601 over 100. Let's see, 100 is a bunch of 2s and 5s. 601, 2 doesn't go into it, 5 doesn't go into it. Yeah, it would just be left 601 over 100. All right, so we have all of this. Do we have any questions on all of this? Cool, so I'm gonna make you do a bunch of them.
Then I'll have questions.
Look at that.
20 minutes later.
Maybe not 20 minutes, but we have 1 through 6 here. The ideas basically follow the same structure as the last six problems. So go ahead and work on these. I'll give you guys 5 minutes. And yeah, if it's horrible, let me know. Yes, sir.
Got a pencil sharpener?
I got a knife.
That'll work.
I don't think I'm supposed to have it in the building, but it's also a baby knife, so.
Thank you.
I have 100% broken out the joke, that's not a knife, this is a knife. It's like a little 2-inch blade. I've told people that I've named it. Some people name their, stuff. Like I named it plausible deniability. It's tiny. When you're holding it, it looks like you might have your thumb up.
That's what she said.
It is. It's a thimble, thank you. The inappropriate equivalent of this meme with the chin.
Thank you.
Yeah, seriously, look at this thing. Yeah, my thumb is actually bigger than this, yeah. Somebody's like, what the heck is that gonna do? Cut rope, cut things that I need to cut. What the heck do you think I got it for? 90% of the time, break down cardboard.
Yeah, I figured.
Oh, wait. All right, so how we feel about this? Has it been 5 minutes? I don't really know. I don't know how to tell time. Oh, hey, there's a clock there. I had a few classes in this room myself, so you'd think I'd know there was a clock there, but you know. Tell them I said hi. Hi.
Says hi.
Who you talking to? Your mom? Yeah? Okay. Hi, Mom.
He said hi.
I love you, Mom.
That worked.
No, I don't.
Gonna make it weirder for you, Mom.
Goodbye.
What's your sign, Mom?
What's happened in my 3 classes ago, huh?
Make sure they interrupt you,
Yeah.
make sure you're awake.
Are you alive? It could be worse. When I was working in the library, I had a jumpstart student accidentally hit her like panic button on her phone because her mom was a helicopter mom. She was on her way to class, was dropping stuff, must have hit the wrong button by mistake. 20 minutes later, somebody busts down the door of the library. Where's my baby?
Yeah.
In that building over there. Went to class, I helped her with her math. That was fun. Unsurprisingly, she got really, really quiet and started dating people that probably shouldn't be dated very quickly afterwards. It's usually how that goes. All right, so how did we do on these? How do we feel? Are these horrible? Are these great?
They're all right.
Doable? Anybody need to see any of them?
Yeah.
All of them, just in case we miss something.
I respect it. I respect it.
Gotta make sure I'm right.
Let me write them down real quick. All right. So 24% is a decimal. Take where the decimal would be now, you move it over twice. It's 0.24. 18% is a fraction.
Did you put just 0.24 or do you have to put the 0?
Technically, you would want the 0 there because you can't just have like a decimal hanging out in space. But I mean, the amount of times I just would have put 0.24 on my own homework is really high. So this would be technically correct. 0.24 would probably be acceptable by most teachers. I'm cool with that. All right, 18% is 18 over 100, then we need to reduce it. 2 goes into 18 9 times, 2 goes into 100 50 times. So we get 9 out of 50.
Oh, 3 for sure.
So question, why do you use 2 or you say 2 goes to 8? Yes.
Because between these two numbers, they're both divisible by 2, so that's the most we can reduce them by. Because 2 fits into 18 nicely and 2 fits into 50, 100 nicely. And we ended up with 9/50, but if it had been like 20/100, then you would have probably gone with 20 fitting into both of them. It just
Okay.
depends on what you have. You go with the largest number that you can break them down in, greatest common factor wise.
Yeah.
Between 18 and 100, the greatest common factor is 2. It's the only thing that goes into both. Now, number 3, we have 15% going to a fraction. So you do 15 out of 100. Now, in this case, they're both divisible by 5, right? So 5 would go into 15 3 times, and 5 would go into 100 20 times. So we'd get 3/20. Number 4, we have 3.02% to a decimal. That one may or may not be intentionally difficult. Irene, you're good on 4, but not 5 and 6. Okay. So number 4, since that one is 3.02%, and in order to convert to a decimal, you have to move 2 decimal places to the left. Your problem here would be that 2 decimal places to the left, there's nothing there, right? So what you could do, you put the point there, and then wherever you're moving it over, you put a 0. Right? There's nothing there, so there's nothing there. So you'd have 0.0302. That make sense to everybody on that one? And the 0.2 to a percentage. That's 20%. I mean, it depends on how you're looking at it, but it depends on what it's a percentage of. So I got the question 5 equals 20%. I assume that's in reference to this one. It's just because 5 goes into both of these. Okay, so. Oh, I see what you mean. Okay, no, I'm an idiot. Never mind. I see what you mean. Yeah, 5 is 20%. That's what you mean. Haha. Okay.
20%?
Number 5 is going to be 20% because the decimal point will move over twice in that direction to get to a percentage. So you would be at 20%. Sorry, apparently gotta work on my reading comprehension and, you know, being a human in general.
So quick question.
Quick answer.
To turn a decimal into a percentage, you have to move it to the left. But to turn a decimal into a percent, you have to move it to the right.
Yeah, so percentage to decimal, 2 to the left. Decimal to percent, 2 to the right. The idea would be that if you have 3.02%, that would be 3.02 divided by 100. And if you do that into a calculator, all that's going to do is shift it over twice. Whereas if you're converting to a percentage, you could also look at this as multiplying by 100, which would do the same as moving the decimal over that direction.
Oh, then you just have to repeat, you have to retake them.
Right, we have 0.356 and we're converting that to a percentage. So that decimal point would move over twice.
Elective
We'd
credits?
have 35.6%.
I never figured that out.
Does that make sense? Ish. Ish.
I don't know.
Percent to the right, decimal to the left.
Yeah, and if you're confused about that at all, like I said, you can look at decimal to a percentage as multiplying by 100 and percentage to a decimal as dividing by 100. Because remember,
Because I don't know how to help. I don't
percentage
know why you need electives. I just know that.
literally
electives
just
are
means
something
per
with your regular. class.
100. So that's the same as essentially dividing by 100.
Press X.
Does that kind of make sense? Just nod your head. Yeah, there you go. All right. Excellent. Good enough. It's good enough for Jesus. It's good enough for me. All right.
No.
I'm a big fan of my redneck voice. I'm out of my Coca-Cola. Golly, that is just
Go get ready for
disappointing.
bed.
All right,
Go get dressed for bed.
worst things have happened. All right, so now that we know how to convert all of these, let's figure out how to use them. So working with percentages. So using some basic math, we can use percentages to give us exact values when comparing to a number. For example, 50% of 12. You can convert 50% to a decimal, which would be 0.50 or 0.5, because you can just, lop off those ending zeros, you don't need them. And to find the percentage of something, you just multiply. So 0.5 times 12 would be 6.
Okay.
So you can kind of see that we can make like a little formula out of it almost. A percentage of some whole number is going to equal that partial number, right? So here's another example. Say you're putting something to a vote and you need a simple majority, so 51%, in order for the vote to succeed. Oh. Hey, you're back. Yes, it was. All right. So you need a simple majority, 51%, for a vote to succeed. There are 6,032 voters. So the amount of votes needed to succeed, you would convert 51% to a decimal, so 0.51. And multiply it by the amount of voters. 0.51 times 6,032, you get 3,076.32. Now, in this case, yes, sir. Walk out of the room, yeah. Yeah, you're good, man. Grandmas are important. I don't got any of those left.
No, 2.
I only had one grandpa. He was a dick.
Grandma's Boy is amazing.
That was a great movie. Well, yes, I would marry Linda Cardellini. All right. Second. All right. So here's the thing with this, because it's a word problem. You want 51% of the votes, you end up with 3,076.32. That means that number exactly is 51%, but you can't get a third of the vote. So in this case, you have to round up, even though normally with any other like level of math, if you're just doing strict math, you would have to round that number down if you were rounding. But you need more than that number to get that majority, so you would go up, so you'd end up with 3,077. Okay, does that make sense?
No.
Oh, that sucks.
Oh, my.
Shame, all right. Well, let's do it anyway. We're gonna do it anyway, okay. I'm gonna do 3 of them, you're gonna do 2 of them, and then we're all gonna be happy about it. You're gonna be happy. All right, hey, look, we got problems. I mean, I obviously have problems, but math problems, specific.
Not
mental.
Pacific.
I've always wanted to go to like a shrink or something, get formally checked out, just so when somebody says, what's wrong with you? I can actually produce paperwork. I feel like that'd be fun to just break out a sheet of
Yeah,
paper.
that is a double-edged sword.
I don't know, all I know,
You shouldn't be driving, you shouldn't be in public.
all I know is I got to tick the disabled box when I signed up to work because of that. And you know what? That makes me a lot harder to get rid of. All right. So we have 8% of 5650. Yeah. So first we gotta convert that to a decimal. So 8% is going to be 0.08. And all we gotta do to find 8% of this is just multiply it. Look at the magic we're producing with the calculator. Oh my goodness. 452. That is it. That is 8% of that. All right, what about 76% of 817? And convert that to 0.76. Multiply it onto that 817. Throw it at Mr. Calculator. 620 and change. Effort, love it. And our last example is we need a 3/5 majority of 5,600 people. Now you could do this multiple ways. We can take that 3/5, divide it, and we would end up with 3 divided by 5, you get 0.6, and you now have a decimal form of that. And you can multiply it onto that 5,600. And we get 3,360. The other way to do it would be, well, if you need 3/5 of 5,600, you could just multiply 3/5 onto 5,600. It wouldn't necessarily answer our, hey, we're learning percentages and decimals. But it would work. But then you'd have to multiply that across. You'd have 3 times 5,600 over a 5. Or you could reduce here and say how many times 5 goes into 5,600. Lots of different things. Personally, I think convert it to a decimal, multiply it, it's a little bit quicker, right? All right, not so bad. Not so bad. All right, well, there's 2 more. Do them.
Oh.
Wow, my.
That's the sound that my parents make when I go home.
What was the last answer of the last sample you did?
Oh, let me jump over here. That was 3360.
Okay, thank you. I
Mhm.
didn't catch it. Okay, thank you. I got it.
Now, guys, just do 4 and 5. I'll give you a couple of moments there.
Let's see.
Or just pipe up when you're done with it. I don't know. I don't know how long it's gonna take people to make that to do. I don't know.
Oh. Okay.
All right. So how did we do?
So.
So in terms of answers,
I got 415.3. Oh, that's it.
effort,
Yeah.
Oh no.
anybody get something other than those 2 answers?
And then the second one, I didn't even know what to do.
A little trickier.
Yeah.
Yeah, I figured that would happen if I threw a 3-digit percentage in there.
Yeah.
That was why I did.
So we're-
Beautiful, beautiful. That was the plan.
Okay.
Number 4, we had 15% of 102 and 5 was 103% of 18. Okay. So 15% of 102. Of course, converting from a percentage to a decimal, you move the decimal place over twice, so you'd be at 0.15. You multiply that by the 102. And you end up with 15.3. Now, the next one, the 103%. Yes, I did that intentionally to see if I could throw you guys off. I know at least partially was successful, so I'm cool with that. Yeah, my handwriting's horrible. So decimal place is in the same spot that it always is, after that number. It's 103%, so it's after the 103. Take that decimal place, move it over twice. You end up with 1.03. Remember what I said earlier. 1.0 is 100%. So if I have 103%, it's going to be over 1. So we're going to multiply that by 18. And we get, I don't remember, my calculator turned off, 18.54.
Yep.
Yay. How do we like those?
Better about those.
Not so bad, right? It's not greatest common factor, least common multiple.
Yeah,
Yeah.
that's for sure.
Let's see, what else we got? So we can take what we've learned and apply it to different scenarios.
I think that's it for tonight.
Huh?
I'm just kidding.
Oh,
I
you're
think that's it
done,
for
That's fair. Oh, don't worry, we only got a few more, well.
Already put in.
You guys, you don't need free time, it'll be fine. You'll be okay. Probably, okay, so. In the last example, we took a percentage of something to find a portion of it. In this case, we had 3 pieces of information. One of which we didn't know, and we used the other 2 to find it. So we had the percentage of something and we needed to know what number that was. Cool. Well, that's kind of how math works. If you have a formula, if there's 3 things that can be in there and you already know 2 of them, you can solve it for that third one. Doesn't matter what you're doing. I could walk into some complicated, horrifying physics problem and I could have a formula on the board. I could have no idea what we're talking about. And I could say, okay, well, that's that, and that's that. So yeah, I can make that work. You don't have to actually truly know exactly what you're talking about. You just got to get the formulas down and be able to work with them, which is going to be significantly more useful of a concept when we get to geometry. This geometry is fun. So let's say you have a percentage of some amount that we have the partial number. So in this case, you have the knowledge that 7% of some number is 56. So this is kind of going the other way. In this case, we have the percentage, we have what we'd end up with, but we don't know what we started with. So you end up solving it algebraically. You have 7% times something, I called the W for no good reason, equals 56. So 0.07 W equals 56. Since that 0.07 was multiplied onto that W, you divide it off. So you'd have 56 over 0.07. Throw that at a calculator and you end up with 800. So again, you can kind of piece together how things are going to work out based on the fact that we just did, oh, a percentage of something is the smaller amount. You take that and say that's 3 pieces of information. If you know any 2 of those pieces of information, you can work out the third. And the exact same thing happens if you don't know the percentage. So if you have 36 out of 450 and you're looking for the percentage of it, you know that some percent of 450 equals 36, kind of like how we have set up on the last bunch of problems we did. So we treat the percentage as a variable. In this case, I called it P. And I said 450 times P is equal to 36. So the percentage times that whole number equals our partial number. And when you go to solve it, you would divide off the 450. And you end up with 36 divided by 450, which is 0.08. So to get the percentage, that's a decimal, you convert it to the percent, you end up with 8%. And yes, that will always work if you're looking for what percentage something is out of something else. You can always divide the partial amount over the original amount. That will always work. So what is the percentage if we have 43 out of 345? So if you remember that one divided by the other is always going to give you the percentage, you can just jump into it. Now, if you don't, then you can remember that the problems we just did always worked out to be a percentage of some amount ended up equaling to a partial amount, right? Kind of how everything was structured a minute ago. Well, in this case, we have the amounts. This would be the partial. This would be the original amount. We just don't know what the percentage is. You can call that any variable. And remember, it was percentage times the original amount would equal to our partial amount. Now, the proper way to write this multiplication would be to have the 345 in front of that x. Since we're just working out percentages, you don't have to do it that way, but it can make it easier to understand, hey, multiplication's happening here, so I would want to divide off. It is not going to be 7.6%. If you divide this by that, you end up with a big old long string of decimal. I'm going to write out the whole thing for no good reason, just so you can see what I'm looking at. No, you don't need to write that out. If you end up with something like this on your calculator and you're like, ew, what the heck do I do there? You're probably good to round. Usually you'll be given instructions, hey, round to this many digits. But I would personally probably round it to 2 or 3 digits. Doesn't look like that third one's very useful to us. So I probably would have just rounded this to 0.13 and then converted it to a percentage. And ended up with 13%. Hey, I have a question. When did my 43 turn into a 45? Oops. All right, well, same idea, but none of those numbers. I don't know how the hell that worked out. That's a 3. That's a 3. That kind of changes things. Okay, so if I did want to round on this one and I was thinking, hey, maybe 3 digits is probably good. The third digit is no longer useless. There's a 4 there. So if I move that decimal over twice, I might round after that, so I would end up at 12.5%. That would work. I was only off by 0.5%. It's fine. Does that make some semblance of sense? Yeah, let's do another.
Mhm.
Okay, if we know that 24% of a number is 402, what is that number? I don't know. Something like 4 times that, something in the 1600 range. 24% of a number is 402. We want to know what the number is. So going off of that same sort of setup that we had before, 24% of some amount. In this case, it's just whatever our number is 402. So I can convert that to a decimal. I can call number a variable, doesn't matter. I could stick with X. I could say I'm multiplying by N. Doesn't really matter. Could draw a picture of a grapefruit if you wanted to, nobody cares. Then you just divide that off. And I get 1,675. And for the record, since these are kind of word problems, if you were answering them and you said n equals, that wouldn't be technically correct because the question isn't asking, hey, what is n? Question doesn't have an n in it. It says, hey, what's the original number? So that's all it's looking for, is just the original number. We're the ones who decided to throw a variable at it.
What happened to the decimal?
That decimal kind of disappears.
No, the one behind it.
Nah. What are we talking about?
I was being a smartass. He said that one. I was like, no, the one behind it.
Uh-huh.
There you go, smart ass.
Show your work. That's all the teacher asks. Is
He's not.
What happened to it? Well, I typed it. And yeah,
Not everyone's smart enough to use the scientific calculator.
all right, well, here's the tutorial.
That wasn't.
402 divided by 0.24. Wait a minute. Not even kidding, at one point when I was like at the tutoring center that used to be here, somebody asked me a question. And I literally did not say an actual word to them, I just kept pointing and going. "Huh. Huh. Huh." Sometimes you can tell that somebody's just being their own roadblock. Like, you can get through this yourself, you're asking me the question, but I know you know how to do it. What percent of 850 is 78? Round to 3 decimal places. Oh, I actually gave an answer there. So that means that our answer at the very end needs to have 3 decimal places. Yeah. Now, I have that written that way for a very particular reason. You can tell it's pretty much the same as the first one, right? Same idea. We have the 2 amounts, we're looking for the percentages, right? So I don't know what the percentage is. Let's just call it P because, you know, that's a letter. And if it's a percentage of a number, then there would be multiplication happening. The word is translates directly to an equal sign. This is 78. You could divide that off. To get that guy alone. And then we can punch that into a calculator and see what it spits out. Now, one thing I do want to say on this. Let me get a couple of digits going here. One thing I want to say on this is that this is not where I want to round. If I'm supposed to round my final answer to 3 decimal places, if I chopped off those 3 everything but those 3 digits, and then I shifted over to be a percentage, I would have 1 decimal place. So I actually am going to end up needing a lot more digits here. So what I'd recommend is to shift your decimal over and then work on your, you know, decimals for your 3 decimals that you're rounding to. Okay. Do it make you sensey? Excellent. How do we feel about percentages? Cool. Let's see. How long was I gonna give you guys on the next pile? 6 minutes? I think I'm gonna pull what I did last time. We'll just save the do it alones for next time. Probably gonna call it good now. If any of you miss me, come on down to the biomat tomorrow morning and I could stab you in the arm.
Where, biomat?
Yeah,
That's right there.
it's over by Target, yeah.
Oh, okay. Is that usually by appointment or you can walk in?
You walk in. The first time you go in, it takes a couple hours, like literally 2 hours, hopefully less. But
If you
huh?
if you have any heart conditions, can you still do it or no?
Hell if I know. I have not been trained on the screening process. I have been trained on the stabby process.
Fine, thank you.
Good night, I'll miss you. But yeah, no, it's I don't know.
I need gas money.
I need waste money. I need to waste a lot of money. I need, oh my God, I'm bad with money management money. Yes, cool. So we're done. Everybody have a good night.
You too, I'll probably see you Friday.
Have a wonderful evening, everyone.
Okay, thank you. Benz, I just how many videos you have from these classes on YouTube? Just 3 classes or 4 classes with this one?
What do we have uploaded on YouTube so far?
Because
Before I started this, I actually, well, I figured out that the internet at this college is significantly faster than my internet at home. So I actually uploaded the other classes to it. So there should be 5 uploads as of now on there. So everything should be up there except for tonight's. Tonight's is probably going to take another half an hour for their servers to process. But I'll try to keep it rolling where every time I come in here, I take advantage of the faster internet and I download the previous class and upload it. I think I'm going to try to keep that going. But yeah, I got last class up there.
yeah, okay, because I was trying to go over and check again, but I didn't see the rest of the class. So what happened with the classes on last winter? It's still in YouTube or there is no, because I didn't find it.
So what I'm saying is I literally just uploaded it. I didn't even put the names on them. Oh wow, 33 views on that class number 2. But yeah, I just got those uploaded.
Okay.
So that is on there as of today. I apologize, I'm very bad about uploading those. If at some point you're trying to check it out and I'm lagging behind on that, just shoot me an email. I'll like immediately make it a priority to upload it. I'm just really bad about it.
Yeah, okay, so thank you, because during the days I'm trying to remember what we got, but if I don't remember really well, so I better go check the video how you did it. So that's why
Gotcha.
yeah. So
yeah, I apologize. I've been very bad about that lately, but I will try to be a little better about it in the future.
okay, so thank you, really appreciate that.
Mhm.
Okay, thank you, have a good night.
All right, have a good one.
Bye, thank you.